Hello everyone, welcome to this video where we are going to explore what we call a line symmetry. So, a line symmetry occurs when there is this shape that is symmetrical, when it is folded and the two parts fit each other exactly. And that particular line in the center, in this case is this line, will be what we call a line of symmetry. Okay? And we usually denote it by dotted line. Okay? So for each of the following figures, let us draw and state the total number of lines of symmetry. So for the first one, let me pull out my ruler where we are going to draw some dotted line. So for this, it will be, there is one here and there is another one here, somewhere in the middle. Two already, right? Is that about all? No, since this is a square, it means that the diagonal, we are then able to have another line of symmetry. Same goes for the other diagonal of a square. So in this case, number of lines of symmetry, 4. As for the rectangle, there's only 1 and 2. The diagonals actually is not a line of symmetry. So if you fold a A4 size paper, you would realize that by folding the diagonal, it will not lead to two equal parts that is exactly opposite to one another. So in this case, there's only 2. As for an equilateral triangle like this, where the 3 sides are equal, there is 1. There's another one here. And there is a third one here. So in this case, there are 3 line of symmetry. And for an arrow, is there a line of symmetry? Yes, there is, right in the middle, horizontally. And there's only 1. The other one with a smiley face. Because of the smiling face, we actually are able to get 1 line of symmetry. And for a regular pentagon as such, there are 1, 2, 3, 4, and 5. We can actually cut the pentagon into 2 equal parts from all the points, okay? So there are 5. Well, for this flag shape, you wouldn't realize that actually it seems to have some line of symmetry, but actually there is none. There's no way I can find a line of symmetry for this shape. As for the star is similar to the regular pentagon previously. We could actually cut them into 5 into half 5 times by looking at the vertexes or the points. So in this case 1, 2, 3, 4, and the last one would be 5. Alright, we have come to the end of this example. So if you like this example, do give it a thumbs up for this video. Thank you for watching, and let's move on to the next example.